Hi, everyone, and welcome to Expo Online, your digital portal for Pacific Marine Expo on nationalfisherman.com. I'm your host, Jessica Hathaway, Editor-in-Chief of National Fisherman Magazine. As part of our ongoing conference and education series, today we will explore the changing landscape of fishing vessel design, construction, and gear technology. The U.S. boat building industry has been running strong throughout 2020, and today we'll look at what's on the horizon for builders and outfitters of commercial fishing and workboats on the West Coast and in Alaska, and in the United States in general. Our moderator today is Paul Molyneaux, the Boats and Gear Editor for National Fisherman and author of The Doryman's Reflection. Hi, Paul.
Hi, Jess. Hi, everybody.
How are you? Thanks for joining us. So also joining us for our panel discussion is we're thrilled to have Jonathan Parrott, a senior naval architect at Jensen Maritime in Seattle, Dr. Sue Molloy of Glas Ocean Electric in Halifax, Nova Scotia, and John W. Waterhouse, principal and chairman of the board at Elliott Bay Design Group in Seattle. Welcome, everyone.
Good morning, good afternoon.
Yeah, so
Glad to be here.
Thank you so much for joining us. So I'm going to turn this over to Paul, our moderator, to get the panel going. Thanks, Paul.
Hi. So I guess let's start with everybody. Maybe we'll start with Sue. Talk about what you're working on these days, and who you are and what you do.
All right. So Sue Molloy, my background is in ship propulsion. My PhD is in ship propulsion, and I've been focused on renewable energy in the tidal power sector and electric boats over the last 15 years. We in Glas Ocean Electric have been working on an electric fishing boat. It's a boat that was converted into a tour boat, but it is a fishing boat, a traditional Cape Islander. And we have converted it from diesel to what we call a dual system, where it's electric and diesel, and you switch from one to the other. The electric is shore powered. It is not charged from the diesel engine. So the big exciting things for us is, one of the big ones is that we are the first boat that was approved by Transport Canada to carry lithium-ion batteries with passengers on board. First boat in Canada, which is pretty exciting, before the ferries. And the battery that we're using will give us approximately, it's intended for the low speed operations. So it'll give us 4 to 5 hours at between 4 and 5 knots. And then if we want to go faster because of the way the power curve goes, it'll be much, much less time. The idea is that this boat does fishing tours. So would take people out on diesel. They'll go on electric for the low speed stuff, and they come back on diesel. And same thing works for lobster fishers or any sort of fishing boats that spend time going slow. So that's what we're working on. We just finished it.
Thanks, Sue. That's great. And Sue also was author of a report on the feasibility of this for small fishing boats, the feasibility of hybrid power. So, Jonathan, would you like to?
Yeah, I'm a senior naval architect with Jensen Maritime, old BF Jensen, which was started back in the early 60s. Been involved in the Pacific fishing fleet for many years. There's not been a lot of new activity except for the smaller 58 footers recently, but we've been working on some concepts for new vessels, 100 footers, 150 footers, taking advantages of some of the new technology. Like Sue, we're doing a lot with electric. We're sending out a fully electric tug to shipyards this week. We've been working on that for basically a year, I think, working with some of the ports down in California and securing funding, investigating different options for power We've also been looking at alternate fuels like hydrogen fuel cells and LNG, trying to determine how best to utilize those in some of the smaller vessels, fishing vessels, or harbor tugs, things like that. So it's been interesting. The battery technology is rapidly evolving. Within 2 years, we're going to have a new chemical composition for batteries, according to one of the battery people that we're using, and it will greatly increase the power density. And then in about a decade, we'll see some solid state batteries coming in, which will further increase power density and decrease the cost, because a lot of them will not be using rare earth materials. They'll be using common everyday materials. So it's very interesting technology right now.
Thank you, Jonathan. Yeah. And John?
Yeah, thank you very much. Like Jonathan, we've been doing a lot of work in the field of alternative propulsion. I just wrote an article for the Passenger Vessel Association looking at what's the landscape look like after diesel. And it's an area that I think has got lots of interest, certainly challenges. And how does all that translate to the fisherman trying to figure out what his next 5 to 10 years is going to look like, is a really challenging question right now, because as Jonathan said, it's a landscape that's changing. We're working right now on the largest lithium-ion battery installation in the United States, a new ferry for Washington State ferries. That'll be a 10.4 megawatt hour installation. Clearly that's not something we'll see in the fishing industry, but I think there is a lot of interest in, can you go to a silent running mode when you're working the pots or trolling. So I think there are ways we can port some of that technology into the fishing industry in a way that's economical and practical. On the fishing vessel side, we've been doing mostly gear upgrades for our customers, new net reels, new winches. We're seeing some interest. Fishermen are always interested in possible new boats. And so we've been playing around with some ideas there, but I don't think the market is quite ready for that kind of capital spend yet. I think folks have looked at some of the certainly on the big vessel projects, the factory trawler side, between the troubles that glacier fish has had due to no fault of their own, but a hurricane can really ruin your day when you make a new fishing boat.
And there's another hurricane heading their direction.
There is indeed. I think everyone's watching the new vessel under construction for the Arctic Storm folks to see how that's going to go. And there's a lot of challenge with the whole pricing structure right now. And I think at some point, until the boats fall apart around them, fishermen are going to try keep kicking that can down the road. But it's clear there's a finite life on the fishing vessels that are out there in the fleet right now, and that day of reckoning is going to come.
Right. Yeah. I mean, the McDowell report, I guess, like the average age of the boats is 40 years old, and the cost of building in the U.S. But now that's one thing. But like you're doing a lot of sponsoning too. Right? Are you designing or are you doing much of that?
We haven't been doing much sponsoring ourselves. That is mostly occurring in the smaller vessels. Mm-hmm. As people are trying to look at how do we increase capacity for the same boat, it's again, they're trying to take their existing boats and make them stretch a little further. And I certainly get that. It's, as we look at new boats, the challenge will be to come up with a new boat that's 1.5 to 2 times more effective and efficient than the existing boats in the market, so that the higher cost of those boats does pencil out. when you start looking at that. Can you operate with less crew? Can you, double the catch, more fuel efficient because you're got newer equipment and gear? I think all those things should be on the table as fishermen are looking down that future path.
And yeah, those are the, I think, if any fisherman looking at a boat is going to be asking, those questions. How can I increase production? How can I cut my costs? And those are, variables. What about coming out of the yard? Do you design around efficiencies and actually building the boat?
Yeah, our company, the motto for Elliott Bay Design Group is better to build, better to operate. We've got a team that has come from a ship building background for a large number of our staff. And so we try to design that kind of production efficiency into a boat from the beginning. Think about, how is a welder actually going to put those pieces together? How is an operating engineer going to maintain that piece of gear? And if I had to say, one of my concerns about some of the European designs is those vessels don't seem to pay as much attention to maintenance and longevity of the boats as we're used to in a North American market. So the ability to change that pump out when that pump is buried behind 3 other layers of equipment is something that I think US designers do a pretty good job of as we try and understand our fishing customers.
Right, right. And Jonathan, I was looking at your webpage, and I was looking at that 58-footer. I guess, is that sort of like, can you tell me about that? What's going to make me buy that rather than a Super 8 or something?
Well, as John said, that we've taken a hard look at how to build these boats, and cut down the number of pieces that need to be put together. As I'm sure John's company is doing, we do everything in Rhino these days, so we're building basically a 3D model of the boat, including all the pieces, making sure everything fits. 10-15 years ago, when we were starting to do the lofting and everything like that, yards wanted 3 inches of green, which means 3 inches of extra material on there, because they didn't really trust the system. And now everything's being cut neat. It cuts down the labor, increases the material weight a little bit, but it's more than offset by 10-15% reduction in labor hours to put these things together. It's something you don't see from the European designs is they're used to having their ships built in markets where the labor rates are very low, $10 an hour compared to our $50, $60, $70 an hour. So you'll see them, they're basically optimizing for weight. So where you'll have a frame that'll be made up of brackets in 3 or 4 different structural members, we'll cut all that out of a single piece of plate. It's a little heavier, but it certainly cuts down the number of pieces that you're involved in and the labor hours. So the 58-footer has that inherent in it, and we've been doing 58-footers since 1970, 74.
I think you guys have been doing it since they invented the tape measure, John.
Yeah, it's we've been involved in that for a very long time. So it's kind of one advantage we also have is we get pounded on some of our designs by Crowley operators. So we've got the shipyard people in staff like John has, and then we've got operators in the next building. They may not be fish boat operators, but they're tugboat operators. They're operating some very old equipment. They know the ins and outs of how to maintain boats and what makes it easier to maintain. So.
Right. Yeah. And so you're mostly repowering existing hulls. At what point do you start to work with people to I mean, you're a naval architect too, right? So at what point do you start designing hulls that are more sort of electric friendly, and what would make a hull more electric friendly?
Oh, now we have, having completed a retrofit recently and doing another one right now, the additional costs of trying to retrofit versus build new they're just they're intense. You when you build new, you can put the stringers in, you can design your hull so that it can have all of its strong sections where you need them, and you can thin it out where you don't need it. We have had to put stringers in to take the torque of the electric motor. We've had to reinforce the hull in certain spots. The efficiency of the hull, sometimes these hulls have wood structures in them that have gotten some wetness along the way that increase the weight, and the boats themselves increase weight over time. So if you can start new, you can have everything designed so that you're catering to an electric system. And you can have every light bulb that's possible LED, even though you have to sort out the VHF issues there. But all the wiring can be done efficiently. You can find ways to make sure that you're even scavenging for power. So if you've got haulers, then every time that hauler lowers down, you can add a little power back into your system. So there are ways of really working and maximizing the efficiency of the electric opportunity if you go new. When you're going retrofit, it's like with a house. You just no idea what you're going to pull back once you lift a few floorboards, right? So we're moving to new boats right away, and taking that whole production line approach. It makes the most sense, where you're gaining your efficiency through scale. You're putting out 4 or 5, 6 of the same kind, so that the team learns how to build it. You know, you know how to install it, and each boat, everything's a little faster. So that's where we're heading to, and I think it's the only thing that makes sense if you're trying to encourage people to use electric systems, because the way to think of an electric boat is you're buying your fuel tank for the next 3 to 5 years up front. And so it's not so much that they are significantly more expensive, but if you're not going to get your payback for at least 5 years, you're buying a lot of stuff up front, and people aren't always comfortable with that. So if you can find ways to bring those costs down, that's critical to the success of this.
Right. And what about new materials? Are you
we haven't really gotten into too much of that yet. I'm intrigued by the idea of bamboo composites, but I'm not sure that the weight of them will be anything better than fiberglass. I mean, fiberglass is a pretty great material. We are looking at mainly just different types of composites that we've been looking at the opportunities there. If you can use reinforcements that might be a little bit stronger by adding in carbon fiber here and bamboo composites there, that's always worth having a look at. But for the most part, fiberglass, the spray up fiberglass is probably the cheapest and easiest way to go.
Right now. Yeah, and so going then back to the and we'll start another round here. Is you're hearing from Dungeness crabbers, I guess, out on the West Coast, Sue, and
So I've actually had a lot of chats with the Alaska Longliners. And they're really, really interested in the possibilities of going electric. I've spent some time chatting with them. They worked with somebody in New England, I can't remember his name, who did a power analysis, and they just looked at where all the opportunities were. And so the problems that you have with a lot of these vessels that go off for a few days is that they have multiple engines or generators to run their refrigeration systems and their power systems, and they go for a long way at a high speed, and then they spend 2 weeks going at 2 knots. So the operational profiles for these boats is really challenging. most of them are overpowered. They're using bigger systems than they need, and they've got the small system for the refrigeration. The one thing that I thought was really interesting from the Alaska Longliners is that they said that when they put out their lines and then they gear down into those low gears so that they can, head out at 2 knots. They said it's like a dinner bell for the whales. And so the whales hear it and they come over and they strip their lines. So they said they had to put their lines out twice, once for the whales and once for them.
Wow.
So there's all sorts of potential opportunity. The other thing is there's a lot of interest in the idea of actually being able to talk on the boat. So the quiet, I'm finding that is, people keep saying to me, what about the cost? What about the cost? It's like, yeah, but there's a quality of life issue that people are willing to pay for. And I think that, if we can't get things cheaper, they're definitely going to be interested in paying things that are the same price or maybe a tiny bit more, just so that they can have conversations and they have that health and safety change to their life, where they're not being exposed to vibrations, so they're not as fatigued. They're not being exposed to the same sort of noise. They don't have hearing problems and hearing loss issues. And then, of course, there's the exposure to diesel fumes at low speed, which is, highly carcinogenic fume that's, circling around a lot more at low speeds than is at high speeds. So there are a lot of motivations to take, make those changes to go electric for the low speed. The big ones, they're for the Alaska folk, they know that their system, that they're using power they don't need. So how do you put in, say, an electric system for all the low power operations and still keep the refrigeration going? So those are challenges that we're looking at to try and see, and whoever comes up with a solution, those guys would be very happy to hear about it.
Yeah. While we're on that topic, John, like the when you're looking at power, I mean, I talked to one guy. He said that lobstermen, like here in Maine, use over the lifetime of the engine about 20% of the available horsepower. When you're designing for, to increase efficiency and lower cost for an operator, like what are your parameters? What are you taking into consideration, and where do you land?
Well, we are certainly facing a change in the way people think about their boats. And by that, I mean, we've been spoiled by having cheap diesel engines that deliver lots of power in a small package. But we're seeing the environmental consequences, and as Sue was pointing out, the sort of health and quality of life issues around a diesel ecosystem. As we talk about new boats and look down that road into the future of the next 10 to 20 years, energy management is the word that comes to my mind. And right from the blank sheet of paper, you start saying, how can I use less energy through more efficient hull forms, through lighter weight materials, through more efficient or less drag on the hull due to appendages. And then, okay, once I've reduced my energy demand budget, then how do I use the energy on board smartly? Can I store some of it for when I'm going to need it later? Can I have things like variable frequency drives on board for fans and refrigeration equipment that will only consume electricity to meet the demand that they have, rather than just, running at a standard set speed all the time? And that's where the technology of the batteries comes in as a great tool for storing energy and then releasing that energy again when it'll benefit you. Whether it's in a slow speed operation, whether it's to run a bow thruster on a very intermittent but high power demand. We're doing that right now for a ferry customer, where we're installing a large bow thruster that's going to be entirely powered by batteries. And those batteries will be charged by excess energy coming off the ship's electrical system. So I think that going and looking at that vessel, and there isn't going to be a silver bullet. There's not going to be this big, aha, I found the solution. It's going to take lots of small changes.
Mm-hmm.
We've mentioned refrigeration systems, ventilation systems on boats is another area as we start looking at when this new COVID age of how do we improve air quality on board for the crews and reduce the chances of transmission of airborne diseases. But how do we also do that in an energy efficient manner? As we look at systems, distributive systems, cooling water, refrigeration, I've already mentioned. How do we make those systems more efficient through, do we go to larger pipe sizes that even though they're going to have a higher capital cost over the life of the vessel because there's less resistance with the larger pipe sizes, is that going to reduce your energy demand? So it's going to be, as an engineer, I'm kind of excited about the opportunities that this new world opens up. And I think it'll be better for all of us, not just the operators, but also our, frankly, we've only got one planet, so we better take good care of it.
Right. Yeah. Yeah. And Jonathan, you're working on like, models, right? Prototype vessels, the big draggers and stuff.
Yeah, we've got, we're looking at all sorts of different options. Efficient hull forms. It's
Like,
kind of
a question about that.
Yeah.
I was thinking, like, when you're using Rhino, I was curious if you have had any surprising discoveries about hull forms that would increase efficiency.
Not really. We use Rhino and then we put it into the CFDs. The issue with efficient hull forms for fishing vessels is that generally, like the 58 footers, they have a limit on size. To increase their holding capacity, they go wider. And a short, stubby hull is not very efficient. And so, you're at cross purposes there. Once you get into the larger fishing vessels, 120, 130, 140 feet, you can begin to take advantage of hull form a little bit better. We've got tools in-house now that 10 years ago you had to go outside to another a big firm that had supercomputers to do this stuff, and now even the small offices have the programs that can check hull forms and resistance. Energy management, as John said, is very important. Take a look at a trawler where it has 5,000 horsepower to drag in the net, but it's only using that power for 15-20% of the time. How do you optimize that? And batteries are a good way to go. I'm sure John's running into the issue with his Washington State ferries is shoreside infrastructure to support the charge on a short term. We've got that same issue with the tugs down in California. Is how do you rapid charge 6.4 megawatt hour battery bank in 30 minutes? Fish boats, there you might end up with a diesel electric hybrid plant where you've got a diesel electric propulsion system with batteries in that the batteries could supply power in a low speed operation while you're jogging along or something like that. The Alaska Leader Group built the Northern Leader about 10 years ago as a diesel electric with Z-drive units in it. They saved $500,000 in fuel costs the first year.
Wow.
And so their payback for going diesel electric was about 4 or 5 years. If they had batteries, the capital costs would be higher, but the savings would be even greater.
Wow.
I like Sue's comment as an epiphany for me is when I stopped thinking of batteries as a capital expense, but think of batteries as an operating expense. They're basically a consumable that you will use up over a period of time, be that 5, 8, 10 years. Choosing that lifetime of batteries that you want to get is an important decision, because the capital cost will vary and the size of the battery bank will vary. But think of it as a consumable, not as a piece of capital. As she said, you're buying a fuel tank up front.
Yeah, I think it's a huge piece of it. And one thing that's very interesting from the battery company that we're using, once you get to your 80% range or 80% life of that battery and you're ready to change, which is anywhere from 5 to 10 years, when you replace it, you replace the cells, you don't replace the whole battery. So now you've got 25% of the cost of the original battery, which is a huge factor in all of this. The other piece is maintenance. There's no maintenance on these batteries and very little on electric motors.
Yeah, we're, in the bigger battery installations, there is some maintenance, because they've got cooling systems and fire suppression systems and things involved. But you're absolutely right. I think the real unknown out there is not right now an existing market for used batteries. But when these batteries are used up after 5 to 10 years, they still have capacity in them for storing electricity. And what's that market look like of, I'm no longer going to put that in my ship?
Yeah.
There's a huge market, I think, landside for reusing those batteries. And right now, we don't know what that looks like in terms of salvage value of batteries. So most of us who are doing this work are just assuming a zero salvage battery after the end of that life, but we know it's not going to be that. There is going to be a demand for those out there.
There already is, yeah. Yeah, I think it's already beginning, because there's the recyclability of them. And then there are some people looking at this idea of land-based storage, because like you say, they're still useful for probably another 5 years before you even want to start recycling them.
Well, what we're doing with Washington State ferries is, in order to get the rapid charging of some of the ferries, we're actually looking at putting a battery on the pier to store the energy charge so we can rapid push it into the vessel when it comes in. But the good news is that when the vessel's batteries get tired, we can rotate those out into that shoreside infrastructure for the ferry system. So they're only buying the batteries once, but being able to use them twice in concept. And that's the kind of thinking that, as we go down this path of new energy, I think there are going to be opportunities cropping up.
And what about, just out of curiosity then, within a small boat like a Bristol Bay gill netter that needs speed at some points and then, is hauling a gill net, how do they take advantage of that? And another thing too is, what about, rather than the rapid charge, exchangeable batteries? Is that something that anybody's working on?
We've looked at those concepts. One of the challenges with swapping out batteries is, you got several hundred pounds, or in the case of the large ferries, tons of batteries. How are you going to do that in a reasonable manner? But to your point on the Bristol Bay boats, we're not going to get away from diesel engines or an internal combustion engine burning a chemical fuel, because you've got that high-speed dash out to the grounds, or more importantly, the high-speed dash back. So on those, you'll still be burning fuel in some kind of internal combustion engine. Maybe that fuel will be ammonia or ultimately hydrogen. But for those kinds of high power output requirements, it's pretty hard to beat the internal combustion technology. But it's when you're on the grounds that I think the batteries will play that important role, as again, that energy storage. Put some aside, use it, put some more aside. And every fishery is going to be different in their approach as to what is the right mix for that fishery. What makes sense for crab boat hauling pots isn't going to work when it's doing tendering. If you're looking at a trawler, that's going to be very different from a longliner. So the industry needs to work with the fishing experts to really understand what those energy demand profiles look like.
And
Yeah, we've spent a lot of time actually measuring them. We spent a lot of time, money, and effort into developing what we call a mobile metering system. So we put it on the shaft, and we measure the shaft power. We have pretty high quality GPS, and we have a good idea of how much power they might use over a day, over a week, over a month, and that's critical because we're learning, just like I believe both Johnsons were saying, that you're using the diesel, you're using the high power for maybe 15% of your day, and then the rest of the time you're using 20%. I mean, I'm looking at one of the charts in front of me here, about 20% of the power that you would actually be needing. It's the difference is incredible. The real solution from an environmental perspective, using your fuel properly, is to actually just have two systems on board. And when you want to go fast, you use one. When you want to go slow, you go the other. But then it gets expensive.
yeah. Now, on the other thing that I wanted to talk about too, I mean, we're getting a good view of how to increase efficiency here with hybrid and how to capture energy. And what about the other factor of fishing, how to increase productivity? And how does, like, when we come up on deck then, Jonathan, like what with some of these new technologies that you were talking about with the designs that you're preparing for when people want to get new boats, what are you talk to fishermen, I assume, and what are they asking for, and what are you able to do?
Well, I mean, what they're asking for is the world for a couple of pennies.
Yeah.
It's always the fishermen just don't have a lot of ready cash, and as John kind of said, that until we get some means for financing these guys a little bit better, we're going to see very few new boats coming online until the old ones fall apart around them. But productivity, I think looking at doing more with less crew. There's a lot of, in the last 10 years, the automation aboard ships has really gone ahead with leaps and bounds. You still have the need for the crew to repair gear, repair the nets. I think the productivity there is design, like on a trawler, design the system so the nets could be repaired quickly and easily, running them between two net reels or something like that. The equipment manufacturers are looking at ways to recover energy all the way through the systems. Any rotating machinery can be used as a generator.
Right.
So they're looking at that. Productivity, automating the processing lines as much as possible. It doesn't help a Bristol Bay gill netter, but some of the bigger boats, I think taking a look at how you actually add value to your catch, instead of just bringing it ashore. The first step was icing the holds and bringing the fish ashore, and then it was RSW systems that allowed the fish to stay fresher longer, and then freezing at sea. So you catch the fish, you bleed it, and it's frozen within an hour after it's caught. It's all sorts of different steps along the way to try to improve the system.
Right. I saw on your website those I guess those RSW trawlers, catcher trawlers, and they're with like a 300-ton capacity.
Right.
So are they delivering to shore side? I mean, what and have you been doing that for a while? Is anybody doing that?
Yeah, we've done quite a few boats. Westward Trawlers delivers a shoreside up in Dutch. You know, the issue there, and you know, the seawater temperature is affecting that. Is how fast can you catch something, and how far away do you have to deliver it? As the waters get warmer, the fish start migrating further north. The distances get a little bit further, so you got to be careful of, you know, when you bring your first fish aboard. You know, it's got to be usually delivered to the plant within 48 hours or some time frame like that. You know, some of the Arctic storm had with the Ocean Phoenix, you know, went out actually to the fishing ground and had the boats delivered directly to the boat right there. Ocean Phoenix is now pretty sure cut into razor blades.
She was an old boat to start with, let's face it.
She was originally built as a President Kennedy back in the early 60s. So talk about reutilizing, being very efficient with material. One way to put it.
Right. Yeah, that sounds good. But what about, like, so, you know, I mean, too, is there's a lot of conversion. People are moving away from hydraulics to electric gear on deck.
Yes, there is. One is that the electric systems have become a lot more efficient and more robust. And the other is running cable is a lot easier than running hydraulic lines. And if a cable breaks, it's very easy to pick up electrons. It's not so easy to clean up a hydraulic oil spill.
Right.
So there's a lot of having to do with the environment. You know, a lot of our harbor boats are going to electric because, especially down in California, they're under a microscope about any oil spill at all. So.
Yeah. Exactly. So, and I was thinking too about safety. How does that play into your design these days? I mean, I remember, you know, about like there, you know, there was you know, some crabbers that have rolled over, overloaded, and stuff like that. And how do you, you know, what do you do? I like, I saw one, you know, I mean, I mean, do you design for people overloading their vessel, or what, you know,
One thing I've heard is designing for people to be able to climb out of a long hallway if the vessel turns over on its side or goes, you know, stern up or bow down. You know, are you designing escape routes for people to be able to get out at the end of a long hallway instead of like trying to climb their way out of a smooth metal hatch, basically?
That's always a consideration. You certainly, you know, we all do stability reports on boats and give them limits on how much they can load. However, you can't prevent the captain from overloading. And, you know, or adding gear and then not paying any attention. One of the biggest things was a lot of these boats were going out with stability reports that were done in the 70s, early 80s, you know, crab pots weighing 700 pounds, and the crab pots now weigh 850 pounds, and they're still carrying the same, you know, they're still the same size, so they're still carrying the same number of pots. I remember some of the early factory trawlers going aboard those and trying to duck and weave through the processing plants. You know, you have to hop over this and then duck under this conveyor and then kind of sideways to get between here. I think a lot of the operators are looking at, you know, more of the ergonomics of the boats, how crew comforts, crew safety. I think that's very important these days because of just how few fishermen are out there, and they want to have a good boat to draw the best people in.
Yeah, that's a really important piece, isn't it? If you can have a boat that's more comfortable. It's an argument that I've always talked about, but I haven't been able to prove it yet. But my guess is if you have an electric boat and you can promise you're gonna be able to listen to your music, you're gonna be able to talk,
Yeah.
you can, you're gonna come off the fatigue you're gonna experience is so much less. The battery company I'm working with has done projects in Norway, and they said that that's a big thing that the crew say as they come off, and they can go out for the night afterwards when they come home because they're not exhausted anymore. These are huge impacts. And then how could you not get the best crew if you have the best boat in that sense, right?
Yeah,
Yeah,
people used to always make fun of
especially
me
with the-
because I wore my earmuffs on deck.
Especially with the tugboats. I mean, the lack of vibration, the lack of noise in an electric boat. I mean, it's going to be eye-opening to some of these people.
Mm-hmm. I put a video online where we switched from diesel on the fishing boat we have, and we switch it to electric, and it just sounds like everything just got turned off, and people are blown away. And you look, and you can see there's a wake. And there's a good wake happening. We're still moving. But the other piece to this that I think is really important, and I think it's part of the environmental discussion too, is the noise, that subsea noise, the underwater radiated noise, URN. And if we're building systems that are electric or fuel cell or anything like that, that you're taking away the ramming cylinders of the diesels and the any of those engines, you've got a bunch of potential. You're changing your cavitation inception point because you're no longer having the same type of vibration on the shaft. And what does that give us as an opportunity for reducing cavitation? And then you've got an incentive to go slower, to use your batteries longer. So that reduces noise and reduces cavitation. And if you can make the environment healthier through not dropping hydraulic fuel, not dropping your oil, reducing the noise, the fish are going to be healthier.
Yeah, we're facing here in the Pacific Northwest, the so-called Salish Sea. Underwater radiated noise is a serious issue with marine mammal populations and the fish populations, and it's becoming a factor in our vessel designs where we're looking at, especially on the new ferries. Ferries are an easy target because they go back and forth every day, and people see them and say, why isn't that boat quieter? BC Ferries has done a lot to actually measure their vessels and try and, with their new vessels, reduce the noise signatures. And on their new hybrid boats, they actually have what they call whale mode. It allows them to run all on batteries for a period of time if they're in the vicinity of an orca pod or so, people are paying attention to it, and I think that's a valuable part of the discussion. But on the safety issue, as a designer of vessels, safety is really job number one. That's why they hire professional engineers, as they're hoping we look out after that. And there's some great technologies on the table now that didn't used to be. Even on a small fishing boat, you can put accelerometers on and get warning limits if you're exceeding, if your roll criteria is deteriorating because you've got too much weight up high or you're getting icing. We can have automated systems that'll alarm. I was talking to a radar manufacturer, and as the radars, small boat radars are now incorporating the collision avoidance technologies that were developed for large ships. So even the guy on a small fishing boat can have the algorithms that tell him if a vessel is going to be a hazard or a danger to him nowadays. After the fire on board that dive boat in California, the Conception, I know the regulatory authorities are taking a long, hard look at egress routes, even on small vessels nowadays as we go forward. So, all this is good because, we want the fishermen to come home to their families at the end of the day. And so anything we can do to help make that happen is an important part of the design brief that we have with our customers.
you get into that level of design of recommending electronics?
Depends on the customer. Most fishermen have a pretty firm notion of what they want for electronics.
Right, yeah.
Far be it from me to argue over his choice of depth sounder or chart plotter or whatever.
Mm.
But I think it is incumbent upon us in the industry to help do articles that will maybe catch their attention and maybe think about some of those issues. Because again, as Jonathan was saying, there's a lot of automation and technologies out there that are not a substitute for safe practices, but anything that can help safety is a good thing to think about.
Right. And you guys, it's not like you're just sitting there designing this vessel from stem to stern. You have a team, right?
Yeah, it's let's face it, ship design is a team sport. It's a small team compared to, say, designing aircraft.
Right.
And the customer is an important part of that team. We've got some customers that are hands-on, want to be involved in a lot of the decisions. Other customers are a little more give us the basic parameters, and then they'll check in occasionally as it goes to make sure it's heading in that direction. So part of our challenge is to match the design team's style to the customer's style.
Yeah.
But yeah, we've got naval architects and structural engineers and electrical engineers and all those people that have their knowledge and talents that we tap into to make sure the design is as well-rounded a design as possible for the customer.
And do you guys from all different firms, do you chat among yourselves about different ideas? Or
it's all top secret. We don't tell anybody anything we're doing.
Well, my feeling is that if it's a good idea, 4 or 5 people are having it at the same time.
Yeah. Right,
Yeah.
right. So, but how big of a team do you have, Jonathan, for example, at Jensen?
You know, when we were purchased by Crowley in 2008, we had 22 people. We got up to, well, when we had the offices in Houston and in New Orleans, we were up to close to 100, I think. Some of them subcontractors. We're now down to 40. So it's kind of up and down. I think John's company is 100?
No, we've been a fairly consistent 50 to 60 range.
Oh, okay.
Last 10 years. We do have offices in Alaska, New Orleans, and an office on the East Coast. But it's you know, the challenge always is that you've got to keep your employees busy, because no one can afford to have them just sitting around waiting for the next project to come in.
Yeah.
So managing that workflow into the office is a critical part of certainly my job in doing business development. And that's why, you know, we like Jensen are involved in more than fishing boats, because let's face it, fishing boats won't pay the bills. So we're involved in, you know, ferries and tugs and barges and shipyard support and whatever it takes to keep that crew busy. But also it allows us to bring things we learned from other industries. As Jonathan was saying, you know, the tugboater with dealing with his gear and equipment every day, I think has got a lot that could educate the fishing industry. And as we look on ferry boats where we're dealing with passengers and their comfort and criteria, how do we apply those to our commercial vessels where we make a better quality of life for the crew members? So it all feeds into itself. Right.
I have a question about that, because I had interviewed a guy the other day who's a cook on boats, and he's worked on different boats, and he says, some boats, they have great galleys, others, yeah, you know. And I was curious about your teams. Is there like a galley person? Is there like an interior decorator? You know?
I'll speak for ourselves. When it comes to specialized things like a galley or on a passenger vessel, if we're doing an elaborate interior design outfit, the last thing you want is for the engineer to be picking the wallpaper and the carpet.
Yes.
So we'll work with professionals in those areas. There's a guy here in Seattle who does galley design, and he does everything from big commercial vessels to high-end yachts. And what a tremendous resource to be able to work with. A guy who really understands what's involved in putting out food for, 30 to 40 people out of something not much bigger than a broom closet.
Yeah.
That's really where that knowledge comes in useful.
Yeah, like, well, for instance, like on a, some of the 140 footers that you were talking about, Jonathan, like, do you have like walk-in freezers? Like, how much space do you give over to crew comfort in a boat like that?
Well, it all depends on what the mission of the boat is, but we have certain guidelines for cubic feet per person per day on dry stores and freezer stores and refrigerated stores. But as John says, for anything over a crew of 6 or 7, far be it for us to design the perfect galley for that. We'll go out to a specialist on that.
Oh yeah. So you don't do that. You don't have anybody. You don't have in-house people that are interior decorators, basically.
No, we used to way back when we hired an interior decorator in, and she was unique to work with. So.
I know who you're talking about.
Huh?
I said, I think I know who you're talking about.
KW?
Yep.
Yeah.
But you wouldn't take a landside galley designer or kitchen designer and expect them to do it on a vessel. This is really specialized knowledge. And this goes with the whole, as Jonathan was saying, ergonomics of being able to work a boat, whether it's how do you position the gear so when you're hauling the gear, it doesn't cause back pain or be a hazard to the crewmen working the gear, to are you investing in sound insulation in the superstructure so that the crew sleeps better at night because they're not hearing the diesel pounding away as much. So I think there's a lot of things, again, that are out there in the industry that we can apply to fishing vessels that will lead to a better quality of life. I was visiting Terrio in Nova Scotia at their building yard, and they were saying one of the reasons the crew members like the larger lobster boats that have gotten wider and wider is because the crew accommodations have gotten better. On the nose of the boat, but because the boat's gotten wider, there's more square feet up there for them to use for accommodation. So it's interesting to see how all that changes and take advantage of the opportunities as they crop up.
Right.
What are some of the most common requests you get for crew comforts?
Well, I would be a little facetious and say a good chair for the skipper.
Yeah. Well, too, John, you were talking about the ergonomics, and that was something, I was a commercial fisherman for 25 years before I got into this one. And that was something that was always bothered me because I'm short, and I used to have to stand sometimes up on the rail to hook up the doors. Dangerous business, so like what new things are you doing to sort of make things, like if I'm on deck, what's on deck? You were talking about designing new net reels and things like that.
Yeah, we're as we lay out the new gear, we're thinking consciously of where are people going to be standing when they're working that gear. Are they getting between the gear and the line forces that are pulling on it? It's funny. It's some of the stuff like ladder slopes. What we would used to accept as a ladder slope in a fishing boat 30 years ago. Nowadays, no, because inevitably someone's going to have stuff in their hands and be going down that ladder, and you'll have a trip and a fall. So what can we do to help move that? Yes, it takes up more space in the boat, but fundamentally it makes it a better boat, safer boat. And so there are lots of things like that as we're going through a vessel and looking at opportunities for where you locate stuff for maintenance, or are you going to give the crew a laundry area that really can work for them rather than it's the last dark cubby in the boat, so let's shove the laundry stuff in there. I mean, those are all the bits and pieces that go to designing a better boat.
Yeah.
Mm-hmm. And
Ladders,
product flow? Oh, sorry, John, what? John?
As John said, ladders, I mean, you know, typically early fishing boats had 60-degree ladders, if not more. Then we started looking at Coast Guard regs and OSHA for 55 and 50-degree ladders, and now all the tugboats that we do, they're saying 45-degree ladders, which is basically land-based ladders. It's just less tripping hazard. You know, little things like that. And because the boats are usually getting bigger, we can put the ladders in properly.
Right on. And what about product flow? You know, I'm like, I interviewed a guy who had a scalloper, and he had a system where the scallops went in at the shucking house. They went down below in the shucking house and moved, you know, in a seamless sort of thing. And I've run processing plants, you know, to keep that product moving in a smooth direction.
Yeah, that's largely determined by the design of the processing line and how they catch stuff. You know, so we try to set the boat up properly for that, but ultimately it's we, you know, once the processing plant people get in there, we move hatches around and to fit better what their particular system is.
I see. So designing the actual processing plant in a catcher processor, again, that's something that doesn't happen in-house. But
No. Usually there are certain manufacturers that are specialists in that.
yeah,
And to tell you the truth, usually after the first season, the boat will come in and they'll pull out the processing plant and totally redo it.
yeah. Oh,
Wow.
right. Yeah.
So we have a couple minutes left, Paul. I just wanted to give you a heads up. We're closing in.
That. And I wanted
Go
to
ahead.
get a little personal here. Maybe just go around and tell us how you know, I mean, I love this job because I get to talk to people who love boats as much as I do all the time. And I know how I fell into it, but I'm curious how each of you sort of, you know, landed in this world of boats. And we'll start with Sue again.
Okay, well, I grew up sailing, and like many naval architects, I wanted to design sailboats. I think a lot of romantics out there, right? And then when I started looking into it, I dabbled a little bit and did small things with America's Cup testing, because I went to school at Memorial University in Newfoundland, and they did a lot of testing of Oracle, and the Australian boats were tested there. So you could pick up some part-time hours to help out with that stuff. And I used to go to the Chesapeake Bay Sailing Symposium, Yacht Symposium. And those were the places where I looked into that world. And then as I spent more time there, say that the machismo and the bravado was not a turn on for me. So I started thinking a bit more carefully about what I wanted to do. I had an amazing opportunity to go into that world, and I think I would have been very happy. The person that had offered me an opportunity was one of the really nice people that I had met there. But I decided to go the route of a PhD because I wanted to look at alternative options for small vessels. I was very interested in small vessels, because we often talk about the ferries and bigger, and we often talk about, you know, small recreational, but not a lot of development. You know, it's much more incremental, the small changes that we make on the boats between, say, 30 and 70 feet. So I was interested in what are the opportunities there, and when you have a PhD, it opens up some international opportunities, because you can walk in with an internationally recognized piece of paper that gives you credibility. So I have, I've traveled and talked to people in Indonesia and other places about this kind of work, and I really wanted to see if I could use the knowledge that I had to try and help do two things. One is energy security, right? You know, once you have diesel fuels, you don't have energy security, especially if you're at the mercy of that, because the price goes up and down, and there's very little that we can do about it. And then the other is environmental, because if we can do something to get these boats off of the fossil fuels, I don't know if everybody realizes outside of our world that there are no catalytic converters on these boats. A lot of these engines are 20, 30 years old. There's no filtration system. Pure emissions are going into the water when we have wet exhausts, and, you know, dry exhausts. It's, you know, I visited the government in one of the Caribbean countries a couple of years ago, the environmental department, and they were doing an environmental audit, an air audit, to try and figure out what their greenhouse gases were going to be so that they could reduce it. And they said, I asked them if they had measured anything from their boats. Nothing, didn't even occur to them. So we have a long way to go, and we need people who have some passion and interest to try and move this along.
Right. Thanks. Jonathan, when did the boat first a boat first capture your imagination?
Well, I've always been drawing ever since I was a little kid. The first, I don't know, epiphany or whatever, was my dad was in the Peace Corps. We were in Africa in 1960 and 61 and 62, and he took me on one of his trips out to the bush. And I remember coming out of the trees onto a beach, and there was a 300-foot passenger vessel with a big hole in its side sitting on the beach. And that's always stuck with me. And, you know, from then on, and then the second epiphany was trying to figure out what to do in high school. And my guidance counselor said, well, why don't you become a naval architect? And I said, what? Says, I mean, there is actually a field that designs boats, and I don't have any clue as how she knew about Webb Institute, but she pointed me in that direction, and that's where I went, and totally happy with what I'm doing. It's still fun. As long as I don't have to manage people, it's great.
That's great. That's a great, yeah. And how about you, John?
Well, I trace my interest back to when I was a young boy. We were living in Vancouver, BC in the early 1960s. And at that time, English Bay, it was the anchorage for all the shipping waiting to come into the port. And there were ships from literally all over the world, and they were just fascinating to me. And so I decided at an early age that I wanted something to do with ships when I grew up. And like Jonathan, it wasn't until I was in high school that I somehow realized that, hey, there are people that get paid to design ships. That's an engineering field. And so I was living in Palo Alto, California at the time, and the University of California at Berkeley had a Department of Naval Architecture. So that's where I did my undergraduate. And then I went on to MIT for my graduate work in naval architecture. And it's been a great profession. It's taken me around the world, literally. Lots of interesting different projects and some really terrific people along the way. And so I feel very blessed.
Yeah. I think
it's the same thing. It's been a wonderful career. I've had lots of fun, met some really interesting people, got to go different places, probably not as many places as the other two have, but
yeah,
it's been fun.
I think that's great. Every screen has a boat in the background.
Well, Jonathan, one of these days I'll have to tell you about going to Russia in 1994 and trying to sell fishing boat designs to the Russian fishing industry. And that was only 2 years after Russia had opened up to the public. And I can tell you it was a wild and woolly place in Vladivostok at that time. So
I bet.
interesting stories where fishing will take you.
I was in St. Petersburg last year looking at the Skip Technics design, the 80 meter vessels that they're building there at Savennoversk. Yeah. That was
I was at a Naval Architecture conference. Pardon me?
I was saying Paul should have to answer the question that he put out to the panel.
What's that? Oh, I was just a kid in Sea City, New Jersey. I can remember it like it was like yesterday. I remember looking out, we went to this restaurant on the water, and I looked out and there were these guys stomping around on a fishing boat. And I was like, what are they doing? They was a fisherman. I said, that's me. And I fished on wooden boats. I worked at Newbern and Wallace even, you know, and in those stinky forecastles with 8 guys crammed down there, you know.
Oh, yeah.
So when you talk about these crew comforts, well, I mean, Lorraine, when my first trip offshore, we were at Lorraine.
Well, I was a trustee at Mystic Seaport for a period of time,
Okay.
and you look at the history of U.S. fishing, it's hard to find a better place than Mystic Seaport where it all comes together. And you realize that the quality of life of fishermen have come a long ways. And yet we've still got room to improve. So that's our design brief, is to do better boats tomorrow than we've done today.
Yeah, we did a story on the Rowan down there at Mystic. Yeah, I fished. Yeah.
I think that is a great note to end on. So I just want to say thank you to everyone for joining us today. And don't forget to continue the conversation on the Vessel Design and Gear Technology thread in the National Fisherman Forum, which you can access with a free website membership at nationalfisherman.com. All of our panelists today have been invited to host a follow-up Q&A there, so you can ask them some project-specific questions. We'll post a link just below this video on the National Fisherman website. And don't forget also that the Expo Online Digital Content Series continues into 2021, featuring both live and on-demand content, all on nationalfisherman.com. Thank you all for being here today, and we look forward to seeing you again soon in person.
Yeah,
Thank
thanks
you.
for coming, everybody.
It was lovely to meet everybody.